Hello there. Today we are here to present our Satcam community exam project and case study on situation in electric scooter company. Our group name is Pravaaha. Myself Indesh Pandit, and I'll be starting with my part of presentation. So here is a mind map on top 10 features for electric scooters app must have. Firstly, it must have simple user-friendly UI experience. Second, it must have proper connectivity with scooter to give real-time details as battery status and range of the scooter. Thirdly, an app must contain an emergency contact info or service contact in case of emergency or breakdown. It must display all the alerts, the apps such as maintenance alert, low fuel, battery issue, and helmet warnings, etc. Then coming to the app must also store all the info about previous servicing and also information about the trips carried out, displaying the data such as distance traveled, top speed, battery usage, mode of vehicle like eco or sport mode, average speed, etc. Now coming to 6 point, the app must support the multiple users login. So it can store the record and data mentioned above for all the users separately. Now, for the 7 point, the app should also provide users with the feature to on and off scooter to an app. Also, it must provide the secure passcode for every different user for their data to be separated. Then, coming to the 8 point, app must have integrated Google Maps feature with all the near locations and important locations pinned, such as hospitals or home or workstation. And also, app must have a feature to upload all the documents such as driver's license, registration papers, insurance, UC, etc. Now, at the 9 point, app must give the alerts via message, alarms if anyone tries to move the vehicle in lock state. It enhances the security feature of the vehicle. Then, for the 10th point, app should be updated time to time for smooth operations. So, these were the 10 features which I have explained via mind map. Now coming to five most useful features would be app must have simple and user friendly UI, which also solves one of the customer complaints above. And it must have proper connectivity with scooter for all real details, for example, the battery status and all. Then it must display all alerts on apps such as maintenance alert, low fuel, etc. App must contain all emergency contact info, and in case of emergency breakdown, or can have put 24 by 7 AI chatbot, which will be helpful to answer all the user questions and doubts. App must also have integrated Google Maps, as I have said, with prime locations such as police station and hospitals listed on it. And also should have an feature to upload the documents such as driver's license, registration papers. This should be directly connected to the digital screen of scooter for modern and easy experience with our scooter. These all points above are the most important and useful features which will make user experience better and solve the complaints submitted by users above. Will build good customer relations and increase the public trust also. Now, coming to the second question, we'll be seeing about some design considerations. Will take as the file type and size limits. We can set that. Then decide what types of documents user can upload, such as in PDF or docs or images. Then for set, we can set the limits for individual files and size as per the user storage input. Then for user interface simplicity, we can allow to upload through the phone camera or files or auto detect the documents that are example RCN license. Then preview and manage the uploaded documents within the app, and easy delete and re-upload options. This all for the easy user interface. Then for security features considerations, we can have encryption, then authentication and access control. We can have our own digital locker. Then we can have backups for all the documents. Then auto logouts if no one is active. Then we can also block the suspicious files which are not currently in use and are some garbage files which may pose a threat of viruses. These are some design and security considerations we can have while designing the storage feature. For next part, I would like to call my fellow mate Rohit Shinde. Okay.
Hello, my name is Rohit Shinde, and I change the and I take the question number three. The question is here that we have the list the potential reasons for the any of the two issues which the customers have complained about us, and we have tested the scenarios you would use the test and ensure uh, then what we can be fixed. So the we have developed that the issue number one, that the scooter does not feel comfortable to drive on gravel or non-terrain roads, particularly at the high speeds. So we have the some causes for that. The first one was the suspension might not be tuned for the rough terrain, or the tire tread may not offer the sufficient grip or cushioning, uh, or any other, that the weight distribution of the chassis might be creating instability, uh, or one of the reason that the handlebar shake at the high speeds on the bad roads. So then we have the some test scenarios would use to test and ensure how we can fix it. Then the first one was we have the ride quality test on the variant terrain types. uh, some example that test on the pothole roads, mud road, stones and gravel at the different speed like 20, 30, 50 kilometers. Then we have the suspension travel and uh, compression test. We have the measure the shock absorber movement and rebound for weights like light wedge, average wedge, or heavy wedge weight. Then the high speed vibration test. We have the utilize the vibration sensors at handlebar or the footrest and the sit on the rough side at the high speeds. So we have to fix up W. Then the stability test under the sudden braking. We have the sudden brake on loose gravel at 40 to 50 kilometer per hour to check the balance and the tire grip. So the next, and then the first issue is solved. Then we have the second issue, that the charger appears to the train with suddenly without warning when there is a less charging remaining. So we have the causes, that the battery calibration problem. The system reads charges in I think it's the percentage incorrectly. So the no buffer power remaining when battery reaches the 0%, which causes the sudden shutdown. So the next one is bad software estimation of the range remaining based on the terrain or riding habits. We have the unreadable BMS. BMS means the battery management system, which we have to readings after prolonged use. So we have the some test scenario also we to fix up this problem. The first one is a battery drain consistency test. We have drive from the full to 0% at various speed, weight loads, and provide the drain pattern. We have the low battery alert timing test. By the timing test, we have to verify alert comes on reliably at 15% and 5% battery. We had also give up app related features for the more accurate. We have the reserve power test also. Make sure that there is a minimum 5% reserve battery available for after 0% reading to avoid sudden cutoff. We have the BMS accuracy over time test. We have run 100 plus charge discharge cycles to test calibration accuracy and degradation pattern detections. We have the range prediction accuracy test also. We have compared predicted range versus actual range under the various condition like city, highway, and uphill conditions or etc. Then the another question is that the using the inside out and outside in technique for releasing a product in the market, and we have the some five steps that we are planning it. Uh, First upon, what is the inside out? Inside out means the put the product on the market while the concentrating on its internal strength. And what is the outside in? Outside in means the put the need of the customer first and then design the product accordingly. So we have the first, we are consider the inside out process, and these are the five steps. The first one is we have to evaluate our own internal strength, like means like we have to make use of our team technology and special qualities. And second one is we have the product testing. We have the verify the app speed, stability, and security. Then third one was the developer recognizable brand identity. That means that by producing visual and messaging that are clear. Then fourth one was the creating a team training demo videos and frequently asked a question as support materials. And the last one is establish a launch plan that includes a timeline, marketing, and beta testing. Then the next one, we have the outside in planning. We have also the 5 points for that. The first one is examine the market to learn about the demands of the consumers and rivals. Then we have established a customers personas and defined our target users. Then third one is get user input through the early testing and practical verifications. We have also prioritized what users actually want, and by concentrating on their UX and features, we have the creative market driven campaign. So we use the social media SEOs and influencers, use inside out to build a strong product, and outside in to the make sure it meets the real market needs. So it's when we combine both, we have the very successful launch. So thank you. The next questions are from my friend Kunal.
Hello there, myself Kunal Desle. Moving on to the further presentation, the question comes if the company is collecting the data in the cloud already but have had performance issues to update collect data and update the app. What can be the reasons of for that and what would need to be improved for the data integration from the vehicle to the cloud and to send the data post analysis to the app. So this business already uses cloud to collect data, but it has the three major performance problems that are information gathering, updates for the cloud, and third one is delivery of app data. And these problems affect data reliability, user experience, and real-time performance. There are major five possible reasons for performance issues. The first one is network latency performance problem. This includes a vehicle to cloud communication that is sluggish and unreliable because of bad internet or signal loss. The next one is ineffective data management. It means that huge amounts of unprocessed data are being transmitted without compression of or filtering, and no delay tolerant upload techniques or batching. So coming to the next slide, the third problem is bottlenecks in cloud infrastructure. This includes server overload or subpar cloud services like sluggish database or APIs. The fourth one is inadequate cloud app API design. This includes data fetching and pushing are delayed by ineffective or unstructured APIs. The fifth one is the absence of processing in real time. It means before data reaches the app, it is not sufficiently processed. Means no aging processing or event-driven architecture. Next, there are also five suggestions for improving data integration. The first one is improvement to vehicle to cloud. This includes use edge computing to pre-process data like filter, compress in automobiles. The next one is that to deal with a outages, employ buffering, and retry the techniques. The second one is optimization of the cloud. This includes make use of scalable cloud service like auto scaling database, serverless, etc. And also the use data stream processing tools such as Kafka, Azure Stream Analytics, or AWS Kinesis. The next suggestion for the same is data storage and organization. It includes this make use of effective formats such as JSON and protobuf and optimized data models. It makes sure databases are organized and indexed to facilitate quick queries. The fourth suggestion is enhanced data flow and APIs. It make use of GraphQL or RESTful APIs with appropriate uh, pagination and caching. Also, it use push notifications or WebSockets to get real-time updates. The fifth suggestion is a post-analysis delivery to app. It means it use event-driven system for post-analysis delivery to apps. Uh, the examples for the same are cloud function triggered after data processing. And the next is to serve process data in an app quickly, to take into account CDNs or cache layers. And this is the image which describe the questions properly. Uh, Coming to the next question, the question is, the company would like the app to have intelligence and provide recommendations to the driver. What kind of data should app collect from the vehicle, and what kind of recommendations can be done? Is there any possibility to use ML or AI for this analysis? And if so, what can be the use cases? So solution for the question is, app is able to gather the categories of data from vehicle and user activity. So here we have taken down the table and we have noted the categories and its data points. It has several categories. The first one is battery and charging. Its main data point is SOC, that is stage of charge, cycles, charging time, and degradation trends. The next is vehicle usage. Its point is speed, distance, terrain type, gravel or road. Also the acceleration braking habits. Next category is environmental. It includes ambient temperature, road conditions, such as through sensors or crowdsourced information. Next category is navigation and GPS. It includes frequent routes, start-stop location, traffic density. And next is the maintenance. It means motor temperature, tire pressure, vibration, error logs. Now in this table, we have noted the use cases, ML and AI, also the approach benefits of the same. Here we have taken the 5 major use cases. First one is intelligent battery management. Uh, it's ML and AI. We can say that predictive modeling of battery health and range remaining based on the usage patterns. Its benefit is it prevents unexpected battery drops, enables better ride planning. Next is adaptive ride suggestion. Uh, Clustering and classification of terrain, weather, and rider style. Its approach is suggest best speed mode such as eco sport and routes. Next case is primitive maintenance alert. Uh, Anomaly detection on motor, tire, temperature, vibration data. Its approach benefit is it reduces the risk of a breakdown, extend vehicle lifespan. Next use case is intelligent route planning. Battery terrain, traffic enabled AI route scoring. So its benefit is suggests most optimal route with lowest charge loss. Next is personalized tips and insights. User preference usage patterns analysis through NLP. Its benefit approach is it customized tips such as you tend to charge at 20%, try charging at 30% for more battery life. So this was the solution for this answer. Next part will be taken by Roni.
So, hi everyone, my name is Ronil. So, coming on to the question. So, what the question is the use product solution concept and create a mind map for the new vision of the vehicle, explain the goal, features, user experience changes, and user UI changes, if any, you want to target in the scope. So, the new electric scooter version involves the goals, features, UX changes, and UI changes. So, coming on to the goals. So the goals is to the become second into the market. So targeting a significant market share and improving a brand competitiveness. The second one is the zero key issues post launch. So striving for a flawless rollout, minimizing the post launch works or failures. Also, the third one is the 50% more sales in 6 months. So aggressive growth in the unit sales within a short period. The next one is the move from 10% loss to 10% profit per unit. So a major financial turnaround aiming for each scooter to sold to a great profit. Uh, Last one is the retain price point. despite all the improvements, keeping the cost consistent for consumers to stay competitive. Now coming on to the features. So features are the fast charging. So it should be less than 4 hours. So improve charging time to boost convenience and reduce the downtime. The second one is the lighter scooter. Enhance probability and performance through the weight reduction. Next one is a touchscreen tablet dash, a modern digital dashboard for better interactivity and controls. Next one is the Google Maps integration. Navigation supports directly from the scooter's display. Predictive battery alerts. So it involves the smart alerts that estimate when the battery needs charging. Next one is the real-time performance logs. So it involves the continuous tracking of metrics like speeds, distance, and energy uses. So coming on to the user experience changes. So these changes are how to user interact with the app or the scooter system to make their experience smoother and more innovative. The first one is the simplified app flow. So easier navigation and fewer steps in app interactions. So next one is the smart onboarding, a more helpful, engaging introduction process for new users. Proactive notifications, timely updates based on the real-time scooter status. Next one is the modular dashboard view, customizable display elements. So user can choose what information is the most important. Personalized ride tips. So it involves a recommendation based on the riding habits to improve the efficiency or safety. The last one is a low battery smart alert. So intelligent notification with the recommendations or nearby charging points. So last one is the user interface changes. So visual and interactive improvements in both app and onboard display interface. So first one is the clean modern interface. So a refreshed design with a focus on aesthetics and clarity. Next one is the bigger buttons, better accessibility, especially while riding. And the next one is the clear icons and labels, enhance legibility to avoid confusion. Next one is the real-time sync with the scooter, instant feedback between the scooter status and app. Uh, Next one is a light dark theme toggle, customizable appearance for different lighting preferences. Next one is initiative tab based layout, logical and easy to navigate structure. Next one is the info hierarchy improvement. Improvement of information is more prominent. Last one is the simplified charge user interface. So better visual cues and easier understanding of battery and charging status. So coming on to the next question. So what the question is the what can be the business and operational metrics and measurement that a company can use for the new version of the vehicle and goal that they have for it. Business metrics can be around revenue, profits, etc. While operational metrics can be around the quality, delivery time, etc. What all the can be the metrics which companies measure their performance when the manufacturing and selling electric vehicles. So coming on to the answer. So answer is to quantify the success of a new model of the electric scooter. The company can embrace a mix of business matrices and operational matrices that are aligned to its strategic objectives, which are growing sales, enhancing profitability, and eradicating early life product problems. On the business front, unit sales volume should be one of the most important metrics as the measure the number of the scooters sold within a given period, particularly within the first 6 months of launching, where the company aims for a 50% increase. Profit per unit and unit profit margin are essential so that the vehicle, which is now running at a loss, now heads towards a 10% profit without a hike in the selling price. Another essential measurement is the market share of the company to shift from the present position that is at the fourth to at the least of the second. In the electric scooter segment, net promoter score, that is NPS, can be utilized to measure overall consumer satisfaction, loyalty, and whereas the customer lifetime value, which is the CLTV, and repeat purchase or referral rate can be utilized to gauge the long-term value each customer contributes. So leads to conversion rate will monitor how well the marketing and the sales efforts are working, and app engagement metrics like the daily active users, session length, feature usage, and give the indications how well the digital experience is carrying over the product. Next slide. So maintaining qualifying and efficiency is more important to prevent the problems that occur within the first version. A defect rate per 100 units and warranty claims within the first month are vital products. Reliability indicators. The objective is to get key issues to zero after launch. So first pass deal, which is FPY, which indicates the number of scooters that make it through quality inspection without rework. Also made a track to lower cost of production. On comprehend how efficiently scooters are being produced. Inventory turnover should be also be monitored by the company to maximize the manufacturing resource planning. Other important operational metrics are the response for the timing to provide for time for servicing to provide a rapid resolution of customers' problem, uptime of charging infrastructure to allow the continuous usability and the report issues in the field to monitor how rapidly issues are recognized and escalated, preferably in the real time through. So collectively, this operational and business measurement give an integrated view of business performance and will inform strategic planning as well as the ongoing day-to-day improvement both throughout and subsequent to launch the new product. So coming on to the next question. So our last question is, if you want to write a detailed test scenarios for testing the battery of the vehicle, what all would be the top 10 to 20 scenarios? Create a mind map, do a relatively priority of the test scenarios based on the most important to least important. So test scenarios for the vehicle batteries to stage of the charge, SOC accuracy, high temperature performance, low temperature performance, thermal management, capacity degradation over time, fault codes and diagnostics, short circuit protection, over charging protection. So coming on to the next slide. So top car battery test situation, order of priority. So SOC accuracy, a precise measurement of battery level, cycles of charge and discharge performance over the time. Thermal management is to control the heat under load. Extreme temperature performance test in hot and cold environments. Degradation of the capacity, long-term battery health, safety check for short circuit, overcharge protection. Equal charge distribution among the cells is known as the cell balancing. Constant power output is known as the voltage stability, and last one is the error detection using diagnostic and fault codes. So this is from our side. Thank you.